Finish up on 1.5. And 1.5, we were working on average rate of change. So I want to do a little bit with that. And then when we do 1.6 tonight, that's dealing with transformations of functions. A lot of graphing on what we're going to be looking at tonight then. Okay? All right, so the big thing with average rate of change is if you have a problem where you're asked for the average rate of change, what you're ultimately doing is you're finding the slope of a line that connects to two points on the function. We call that a secant line. So if your focus just is totally on, I need to get 2 points and then find the slope, that's really what average rate of change is. So really with this one, this is supposed to be modeling a ball rolling down a ramp, but what you're given is you're given this function. You know, if you study physics one day, many of you are going to do that, of course, is, you know, you have a position function. S of t represents where that ball's position is at some particular point in time. And what you're doing on this is you actually have 2 times. So if the first time is 3, you're going to get a point. So you need to go ahead and find S of 3. So that's going to be 11 times 3 to the second. So that's 11 times 9. So S of 3 is equal to 99. So what that's going to mean then is that you just have a point when t is 3, then the position is 99. So that's half of the problem, is just making sure you got your first point, okay? Then you do the same thing with the second point. So you have, it looks like you have T2 is 3.5. So you would do S of 3.5. So that's going to be 11 times 3.5 to the second. You can do that just in your calculator. I'm going to get my calculator up here and we'll just do that real quick. And guys, I'm just doing one step. I just go 11 times 3.5 to the second. Okay, and I'll just take whatever decimals we have. So that's going to give 134.75. So what that means is when the times 3.5, then the position is going to be 134.75. Okay, so that's what that means. Now, we're not going to bother graphing on this. I mean, you could, but you don't really need to. Whoops, what in the world did I just do? There we go. Okay, so what we want to do, when you do the average rate of change, tell me what you do. What do you ultimately do now? Find the slope. Okay, that's what it is. Okay, so you got these 2 points. Okay, so just pull out your slope formula. You don't have to write your slope formula down. Remember, you're just doing subtract the y's, that gives the rise, subtract the x's, that gives the run, and you pick the order you do it in, but you want to be consistent when you do that. So what we'll do here is we'll just do 134.75 minus 99, and then that would be all over 3.5 minus 3 like that, and then we just use a calculator, okay? Oh, why is it doing? There we go. That's what I needed it to do. Okay, so we'll do 134.5 minus 99. Oops. Damn it. This thing is so hard to use sometimes. Okay, so that's going to give me 35.5, it looks like. And then, of course, the bottom is going to be 0.5. So I'm just going to take that number and divide it by 0.5, and that's going to give 71. So the average rate of change is 71. Okay, that's what that means. Okay, everybody understand what I mean by average rate of change? Okay, that's like I talked about last time. That's a real big deal when you take Calc 1. You'll talk about average rate of change and then what instantaneous rate of change is. That's where the calculus kind of idea begins. Okay, this next problem is the same thing, except it's given something about taxes and charitable contributions. What you're doing on this one is you're finding the average rate of change between 1995 and 1997. So actually all this is going to mean is you've already got a point. So that right there would be considered a point. And then 1998 right there would be considered a point there. So if you're going to find the average rate of change on that, you're just going to do the slope again, right? So you're just going to do, these are the y values. So you find the distance between that. That would be your x values or your run. So it's just rise over run. So what you want to do on this is just do, let's see, 3,200 and minus 2,450, and then divide by 1998. minus 1995 like that, okay? And just use your calculator to get the value on that then, okay? So let's say it looks like 3,200, and then subtract the 2,450. Okay, so that'll end up giving me, it looks like 750, and that's 3. So if you do that, then you got your average rate of change. Okay, so the average rate of change is just comparing 2 points on that. And of course, that average rate of change is going to be generally different between 2 years like that. Okay, all right, so that should be like real straightforward. Yes.
I just use 97.
What's that?
It's 97.
1995 to 1997.
Oh, I do.
98. 95 to 98.
Okay. Why don't we do this? Okay, why don't we change the problem? How about that? My apologies. Why don't you just say, change that to 1998? You would do the same thing, right?
Yeah.
Okay. Teacher's just blind today or something. So I even highlighted it. Okay, whatever. Okay, yeah, just do that, and then that'll take care of that, because I don't want to spend a whole lot of time on that then. Okay, so let's change that to 1998. Okay, I think I saw that 1998 there. That's my excuse. Okay, any questions about anything? Okay, everybody good? Okay, all right. So I'm going to go ahead and pull up the 1.6 here, and what I want to